welcome to the Routing Room, and today we're going to level up our knowledge on subnetting. Ooh, spooky, scary subnetting. All right, let's get into it. So, the purpose of subnetting is to break down larger networks into smaller, more manageable networks. And we do this so we can enhance performance, security, and organization of our networks as a whole. Now, there are some things that subnetting is not designed to do, as with anything. And the things that subnetting is not designed to do, without a doubt, is it's not designed to make exams harder. It's not designed to make your life as a network administrator harder. And it's not designed to make network engineers try and lose sleep at night. Even though these things do occasionally happen, it's not designed to do that. So what are we trying to solve with subnetting? Well, first thing we're going to try and solve is how many subnets do we get based on a given problem? And I say first thing, and by first thing I mean we'll discuss it later in this video. How many hosts do we get in each subnet? And there's a formula for this. So the total number of addresses we get from a subnet we can obtain by taking 2 and raising it to the number of host bits that we have available to us. Now this gives us our total addresses, but it doesn't tell us how many usable addresses that we have. There is a difference between the total number of addresses that you get in a subnet versus how many are actually going to be usable. And all we do to get usable is we just subtract 2 from our total number of addresses. Take 2, raise it to the number of host bits that we have, and then we take that and we subtract 2 from it, and that gives us our usable addresses. Why 2? Well, the network ID and broadcast, those aren't usable addresses that we can assign to hosts or to endpoints or whatever verbiage you want to use. We can't assign those addresses to a device. And lastly, we want to figure out where does each subnet start and where does each subnet end. Now, the way that I do this is how I was taught in my tech school. It's probably going to be different from what you've learned or have learned in the past, but we're going to jump into it. It all comes down to memorizing this chart right here. You can memorize this chart and the NFLBX, the network ID, first assignable, last assignable, broadcast, and next network. Then you will always have a quick way to write down out a subnet. You can quickly write this down when the exam starts, and you'll have your little subnetting cheat sheet there next to you, all legal and part of the process. So there is a process for how this chart is intended to work. And how that works is we're going to do this 2 ways. The first way is we're going to get an IP address and a CIDR. Let's say we're given 192.168.70.100, and let's give it a CIDR of 27. Well, let's say the question asks us to find a subnet mask. Well, how do we find a subnet mask based on the CIDR? Well, how we're going to do that is we're going to figure out where 27 is. It's in our 4th row. So anything above this, we can basically mark all the bits as being used. And if you mark all the bits as being used up until the 4th row here, we get 255, 255, 255, and then lastly, we're going to take 128 plus 64 plus 32. That gives us 224. And that is our corresponding subnet mask to our /27 CIDR. And how we got the 255s is we're basically counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so on and so forth. If we're marking them as being used, we're adding them together based on the topmost numbers. So first octet, 1 through 8, that's all used, that's 255. Second octet, that's all used, 255. Third octet, these are all used, 255, and then we stop right here. Take some ink away here. rewrite our address here. I think that's what it was. Okay, so now that we have our IP address and our subnet mask here, let's go about getting our subnetting piece done. So step one is we're going to take this /27, we're going to identify it on the chart. Bang, right there. Now we want to tie this, step one, we're going to tie this to the topmost number. Bang, step two, 32. Now, 27 lies in this fourth row here, right? 1, 2, 3, 4. So that means we're working in the fourth octet. I'm going to underline that. That's where we're going to be working in. And then now we want to start doing some incrementing. We're going to increment by 32s starting at 0. And the goal here is we're trying to find a range that encompasses the octet that we're working in. So we're trying to find out where 100 fits in to the ranges here. The 0 to 32, we have a range of 0 to 31 for our first network. Does 100 fall within there? Nope. Does it fall within 32 to 63? Nah. Fall within 64 to 95? Nope. What about 96 to 127? Oh, well, by golly, wouldn't you know it? 100 falls between 96 and 127. Wouldn't you know? So now we have our range that this network, this /27 is a part of. So we're going to start with the network ID. Network ID for this is 192.168.204. Dot. What do you think it's going to be? 96. Bang. This number right here, that's going to be our network ID for the octet that we're working in. So now to get our first assignable, all we're going to do is we're going to add 1 to our network ID. That makes this 192.168.204.97. I promise this is a 0. 204, I promise. All right. Now we're going to take a jump. We're going to jump down to the next network. And to get that, all we're going to do is look at the next network over here. So the next network, the next /27 after the current /27 is 192.168.204.128. And now we're going to work backwards. So to get our broadcasts, all we're going to do is subtract 1 from the next network, which is 192.168.204.127. And finally, our last assignable, we're going to subtract 1 yet again, and we're going to get 192.168.204.126. Bang! And you just submitted using the chart for the first time, maybe. All right, and this answers a couple of our questions from the last page. It answers how many addresses we have total, right? We have all the way from 196 all the way to 127. That's our total addresses. And then if we subtract these guys, well, there's our range of usable addresses all the way from 97 to 126, which is most likely the type of question you'll see on a Network Plus or CCNA exam, I would imagine. It's something asking you what is the range of usable addresses, or what is the range of total addresses for a given network with a CIDR or network with a subnet mask. Using this chart, you can do it all. Now let's do one more. We're going to do a bigger network this time. Let's say we're given 10.20.30.40. And instead of a CIDR, we're going to do just a subnet mask this time and work to get our CIDR. .192.0.0.0. Well, working from what we did the last time, if we have 255, that means this whole row is taken, right? And then to get 192, we take 128 plus 64, and that gives us 192, which means this is a /10. We're in our second row here, which means we're working in the second octet. And now we're going to start doing our incrementing. So 0 to 64 covers 0 to 63 for our actual network range. And wouldn't you know it, 20 falls within that first range for us. That means our network ID is going to be 10.0.0.0. Fun fact, if the subnet mask ends in 0, the network ID will always end in 0. Now to get our first assignable, we're going to do the same thing we did before. We're going to add 1 to our network ID. So what do you think our first assignable is going to be? Well, if you said 10.1.0.0, you are incorrect. The first assignable is 10.0.0.1. So if we back this up a minute and think about it from a purely mathematical standpoint, if I gave you the number 10,000, and I told you to add 1 to 10,000, what number would you get? You would get 10,001. Same mathematical thinking applies here. Add 1 to the furthest right that you can add the 1 to. Now to get our next /10 network, well, we already have it right here. This is the network ID for our next /10 network. We get 10.64.0.0. And just like before, we're going to subtract 1 from this to get our broadcast, which is 10.63.255.255. Because in binary and IPv4 land, if we're subtracting 1 from 0, when we take away that extra value from the left, just like we do in base 10 mathematics, the number that we can only roll back to is 255. So we took the 1 from 64, made that 63, and then we got 255. Just like you do in your base 10 general mathematics, right? So just like with base 10 math, if I take 10,000, I subtract 1, well, I have to take 1 from the furthest most left place. I get rid of the 1, and then with base 10, we roll back to 9, which makes this 9, 9, 9, 9. But we don't have 9s, so we can just roll back to, in binary, we have to roll back to 255s. So to get our last assignable, we're going to subtract 1 again, which makes this 10.63.255.255. 254. And that is how you subnet using the chart. So on to the next. The next question we need to solve is how many subnets do we get based on a given problem? Let's say we're given an exam question that says, given a certain /24, how many /27 networks can we create? Let's say we're given 10.0.0.0/24. The question is, how many /27s? Well, to do this, we're going to take 2 and raise it to the power of the number of borrowed bits that we have. Well, what are borrowed bits? Well, to get borrowed bits, we're going to take our new prefix and subtract our original prefix from it. So our new prefix being 27, our original prefix being 24. Leaves us with 3 borrowed bits. Now to get our total number of subnets, we take 2 and raise it to the number of borrowed bits, which gives us 8 total subnets. So if you see an exam question that says, hey, how many /27s can you fit inside of a /24? The answer is 8. Fit 8 /27s inside of a /24. Now, what does this break down to? Well, if we go back to our previous slide, let me clear the ink off of it. Well, we have a /27, which means we can increment by 32s. So we go 0, 32, 64, 96, 128, 60, 192, 224, and that is it. So we have 1, 2, 3, 4, 5, 6, 7, 8 networks, 8 /27s that can fit in a /24. We have 0 to 31, 32 to 63, 64 to 95, 96 to 127, 128 to 159, 160 to 191, 192 to 223, and 224 to 255. These are our /27s that can fit inside of a /4. So now let's dive a little bit deeper on this and look at something called Variable Length Subnet Masking, or VLSM. Now, without VLSM, every subnet has to be the exact same size, which can be a massive waste of IP space. And what VLSM allows us to do is we can size each subnet exactly for how many IP addresses that it needs, which is a far more efficient use for our IP space. So let's start with some steps here. We're going to start with a base network. Let's give ourselves a base network of 10.10.10.0/24. And let's list out some subnet requirements. So how many hosts do we need here? Let's say we need a subnet of 30 hosts, one of 100 hosts, one of 2 hosts, and we'll do one of 8 hosts. We'll start from large to small. So if we just erase what we just did, 138.2. $138.2. We're going to assign the largest subnet first, and then we'll keep going until we're done. So, what subnet can we use that contains, or that will contain 100 hosts? Well, if we recall back to the chart, so we need 100 hosts, 30 hosts, 8 hosts, and 2 hosts, right? So let's take a look at our 100 hosts first. So which CIDR will hold 100 hosts without going under 100, without going over 100 hosts? What's the biggest subnet we can use? Sorry, the smallest subnet we can use. What is the smallest subnet that we can use that holds 100 hosts? So if we have a /24 to work with, what's the smallest CIDR we can use here? Well, if we look at the /25 here, right down our network here, 10, 10, 10, 0, /20. So if we look at the /25, that would put us at 10, 10, 10, 0 for our network ID. You recall the steps, right? Step 1, step 2. We start incrementing. Well, that's 128 total hosts right here. That covers our 100 hosts easily. Well, can we increment by 64 and get 100 hosts in one network? No. The smallest subnet that we can have that it will hold 100 hosts is going to be a /25. So that's /25, which makes our network ID 0, our first signable .1. Our next network is 10, 10, 10, 128 /25. Makes our broadcast 127 and last signable 126. So the subnet that covers 100 hosts is 10, 10, 10, 0 /25. There's our 100 hosts. Gone. Bang. Easy. So now, what covers 30 hosts for us without causing us problems? Well, let's erase this. We just did this. A little more to erase here. So now, that whole first /25 is done, taken. Can't use it anymore. We have to start with the next /25. How can we break up this /25 to get us 30 hosts? Well, 25 is going to be too big. We already established that's 100 hosts. Or that takes up 100 hosts for us. So that's too big. Will it fit 30 hosts in it? Yeah, it will. But we're looking for the smallest subnet we can have to fill up the host count. We can look at this /26. Well, we increment by 64. Well, that covers 30 hosts. But can we go smaller? Yeah, we can go smaller. Let's take a look at 32. If we increment by 32s, it gives us 0, 32, so on and so forth. But we can start with 128. So we can start at 128 plus 32, that's 160, 159. So here is our /27 range that covers our 30 host requirement, which makes the network ID this guy right here, up here, 10, 10, 10, 128. Makes first signable 129, right? Now what's the next network? Well, the next network is going to be this guy right here, this 160. 10, 10, 10, 160. Which makes the broadcast 159, makes last signal 158. All right, so that takes care of our 30 host requirement. So we have 10, 10, 10, 128 /27. And that takes care of our 30 host requirement. All right. Now we're down to 8 hosts. And this is where we're going to get a little bit tricky. So if we take a look at a /28, right, if we increment by 16, yeah, that gives us plenty of space. That gives us 14 usable addresses, right? 0 to 16, 15. Yeah, that's 14 usable addresses. Yeah, that covers our 8 host requirement. But can we go smaller? Can we go to 8, increment by 8? That's 8 addresses there, right? 0, 1, 2, 3, 4, 5, 6, 7. That's 8 addresses, right? But it's not 8 usable addresses. Not 8 usable. Remember, we can't use our network ID in our broadcast. So if we have a requirement for 8 hosts, that means we need 8 usable addresses. So that means that we have to go with a /28. Because while that gives us 14 usable addresses, which is a little bit more than what we need, it is the smallest subnet that we can use that encompasses our total of 8 hosts, but doesn't give us less than 8 hosts. So to do a /28 here, remember our next network was 160. We have 10, 10, 10, 160 /28. So we'll start with 160. We'll increment by 8. And the only reason we know we can do this is because you take 160 and divide it by 16, you get 10. So you know that 16 goes into 160. We can just start at 160. Plus 16, that's 172. So our range is 171, 160, 171. So our network ID is 10, 10, 10, 160. Our first signable is 161. Our next network is going to be 10, 10, 10, 172, which makes our broadcast 171, and our last signable 170. And that takes care of our 8 host requirement. So we have 10, 10, that's a 10, I promise. 10, 160, /28. And something applies for 2, right? We've already used this. Can't use 8. Can't use 2, right? Because it only gives us 2 addresses, which is used for very special cases. But if we need 2 actual hosts, we have to use a /30, which gives us 4 total addresses, 2 usables. Then we will subnet this out 10, 10, 10, 172. /30. All right, so we have 172, 176, next range 175. So our first signable is 173. The next network is 176. -1 gives us 175 for the broadcast, and 174 for the last signable, which this is an address, and that's the usable address. So /30 gives you two usables. Typically something you would see in a point-to-point type of connection. So our last is 10, 10, 10, 172 /30. And that fulfills all of our requirements for VLSM. So, with that being said, that concludes this video on subnetting, and I will see you in the next one.